Hello, my wonderful students. You're welcome to another edition of Eko Learners Support for WAEC and NECO candidates. My name still remains Oluwaleke Animation. Today, I'll be teaching you a very important topic, which is balancing of redox reaction. Sit back and relax and enjoy the journey.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
So we hope to achieve this at the end of the day. You should be able to identify redox and non-redox reaction, and we should be able to balance redox reactions. What are redox reactions? Redox reactions are usually more difficult to balance than those reactions that do not entail oxidation in our reduction. Remember, in our previous classes, we have already told us what oxidation and reduction is. So there are two basic methods for us to do balancing of redox reaction, and these methods are half-cell reaction method and the oxidation number method. In the half-cell reaction method, the commonest way to balance redox reaction is by considering the two half equations involved in the reactions. What do we mean by this? The first thing is for us to identify the oxidizing agents and the reducing agents. Remember, students, in our previous class, we have already said to us how to identify oxidizing agents. Oxidizing agents is the one that undergoes reduction. Remember, oxidizing agents, reduction. While reducing agents undergoes oxidation. So with that knowledge, we'll find it very easy to identify the oxidizing agent and reducing agent, which is the first step in balancing our redox reaction. The second step says, write the half equation for each of the oxidation and reduction, and balance the atoms and charges by doing the following. The third step says, ensure that the electron loss in the oxidation half equation is balanced by the electron gain in the reduction half equation. What does that mean? The fourth step says, add the two half equations to eliminate the electrons and get the overall redox reaction. For us to understand in details those steps that we just mentioned, let us take a look at this question. Write a balanced ionic equation for the redox reaction between acidified heptaoxodichromate 6 ion and the chloride ion. As you remember, our first step, students, we identify the oxidizing agents and the reducing agents. Looking at it very well, this is heptaoxodichromate 6, meaning the oxidation number of chromium. The oxidation number of chromium here is +6. That is why it is called heptaoxodichromate 6. That 6 is for chromium and not for any other element. Why this one, the oxidation number is already showing. It is +3. So it is moving from +6 to +3. What do we call such, students? Thank you very much. Oxidizing agents. So this man here is the oxidizing agent. Why is it the oxidizing agent? Very simple. It undergoes reduction. It undergoes reduction. It's not a reducing agent, because a reducing agent tends to undergo oxidation. Remember, I told you that it can be confusing. Somebody can easily say oxidizing agent undergoes oxidation. No. Oxidizing agent does not undergo oxidation. So oxidizing agent does not, because you can easily fall in your mind that oxidizing agent, of course it's oxidation now. Ox, no, that's not it. Oxidizing agent undergoes reduction as this ion is doing. It's undergoing reduction from +6 to +3. So the chloride ion is a reducing agent, of course. You should know that it's a reducing agent. Why? Because it is oxidized to chlorine. Oxidized to chlorine. How do we know that it is oxidized to chlorine? Remember the definition for oxidation. Oxidation means increase in oxidation number. Increase in oxidation number. So student, let's check. Is there any increase in oxidation number? Can you spot it? Very good. That shows you have been revising what we have been doing in our previous classes. There's surely an increase in oxidation number because the oxidation number of chloride here is -1 and the oxidation number of chlorine here is 0. Remember we mentioned in our previous class under the rules for determining oxidation number that the oxidation number of an element in a free state is 0. So you can see this chlorine is in a free state. It's not combined with any other elements. Somebody can say at home that, but this one too is in a free state now, it's not combined. No, this is not chlorine gas. This is a chloride ion. It's a chloride what? Ion. And we also said in that rules that the oxidation number of a simple ion has the same size and sign as that displayed on the ion. So the oxidation number of chlorine is -1. Here it is 0. So it's moving from -1 to 0. -1 to 0, you agree with me that is an increase, it's not a decrease. So, and that's the definition for oxidation number. Oxidation number involves increase in oxidation number. So that clarifies or emphasizes that truly chloride ion is a reducing agent because it undergoes oxidation to give us chlorine. So step 2, what do? We balance the number of atoms by adding the correct number of what we see displayed on the screen. Let me explain it in a very simple way. Balance the number of atoms. How do we balance the number of atoms? If you look at it very well, there is 7 oxygen here. There is 7 oxygen here. Before this water was added, remember the water was not there before. This was not there before. They are foreign. They were just added. So let me tell you how they got the 7 water. Since there is 7 oxygen here, the rule says you balance it by adding the correct number of water molecules. So 7 oxygen can be balanced by adding 7 water molecules. Because in 7 water molecules, we have 7 oxygen. If this were to be 4, see how to O4, 2 minus. If this were to be 4, I wouldn't have put 7. I wouldn't have put 7. If this were to be 4, how many water molecules will give me 4 atoms of oxygen? Very good, very good. That shows that we are attentive. 4 molecules of water will give me 4 atoms of what? Oxygen. So take notes. There is 7 water here because there is 7 oxygen here. Now, in trying to balance oxygen, we have created another problem. Because now there is hydrogen here, but there was originally no hydrogen on this side. Remember I told you that this man and this man were just added to balance it, following these steps. So, since we have added 7 water, then I have to what? Find out how many hydrogen has been introduced to this side. How do we balance hydrogen? No, not by adding water. We balance oxygen by adding water. But we balance hydrogen by adding hydrogen ions. That is the rule. We balance hydrogen by adding hydrogen what? Ions. So that's why there is 14H plus here, students. 14H plus. So you can see it is balanced now. It is balanced. So that is how this step were derived. Now let's move on. Balancing number of charges. That's the next one. Balance the number of what? Charges. How do we balance number of charges, my dear students? Very simple. You have already balanced the number of atoms. I would advise you, always confirm before you go to the next stage. What do I mean? Confirm. We have 2 chromium here. We have 2 chromium here. Chromium is balanced. We have 7 oxygen here. We have 7 oxygen here. Oxygen is balanced. We have 14 hydrogen atoms here. And we have 14 hydrogen atoms here. I believe you don't understand how I got 14. 7 times 2 is 14. So hydrogen is also what? Balanced. So atom-wise, it is balanced. So the next for us to balance is charge-wise. How do we balance this charge-wise? Please, relax and see what I will do. To balance charge-wise, we'll just simply calculate the charges on the right side and the charges on the left side. If you look at it very well, this is -2, -2, and this is +14. Yes, you can see +1 here, but it will be multiplied by the coefficients. So +1 times 14 is +14. -2 plus 14 is +12. -2 plus 14 is +12. So we have total of +12 on this side of the divide. Now, what do we have on this side? We have +3 times 2, which is what? +6. Which is what? +6. So, and on the right hand side, that is there, you have +6. That's how they got +6. You might ask, why am I not adding what is there? Your guess is as good as mine. There is nothing there because this is 0. So 0 times 7 is 0. So there is nothing there. So we have +12 here and we have +6 here. 12 to 6, remember, it's reduction. So we need to add 6 electrons to the left-hand side in order to balance the charges. We have +12 on this side. We have +6 on this side. For us to balance it, we need to add +6 electrons to the left-hand side for us to balance that. You might say, teacher, but 12 plus 6 is 18. And this side is not what? 18. No, don't get it wrong. These are electrons. They are negative. So this +6 electrons I wrote here is just, can be likened to me adding +-6. So if I say 12 plus -6, you agree with me that the result is 6. So at the end of the day, both sides are what? Equal. So that is the reason why this statement comes into play. We add 6 electrons to the left-hand side to balance it charge-wise. Let's move on. Yes, the other half equation, oxidation half equation. Remember, we call it oxidation half equation because it is undergoing oxidation. It's as simple as that. It's undergoing oxidation from -1 to 0, which is oxidation. How do we balance this? This one seems simpler than the other one. This one, there is no missing atoms. This one, we have just Cl, we have Cl. So the number of atoms is balanced. You can see the number of atoms is balanced in this equation. Why is it balanced? Because we have 2 chlorine here, we have 2 chlorine here. So we'll go to the charge-wise. We have balanced it atom-wise. We'll go to the charge-wise. How do we balance it charge-wise? The total number of charges we have here is -2. You agree with me? -1 times 2. -1 times 2 is -2. So total here is -2. Why total here is what? 0. So let's go to the oxidation half equation. This is oxidation half equation because it is undergoing oxidation. So from -2 to 0. Now, if you look at it very well, the atoms are balanced. We have 2 chlorine here, we have 2 chlorine here. So it is balanced atom-wise. We'll go to charge-wise. Charge-wise, we have -2 total here, -2 total here. The other side, we have what? 0. So how do we balance it? How do we balance it? From -2 to 0, it's oxidation. It's oxidation. So oxidation simply means loss of what? Electrons. So for me to balance it, remember in the reduction half equation, I added electrons to the left-hand side. Here, for the oxidation half equation, we add electrons to the right-hand side. Right-hand side. So for me to balance it, I'll add plus 2E minus to the right-hand side. We add plus 2E minus to the right-hand side. So that's what has been done here. So let's move on. So at the end of the day, we have this combination of all what we have done. Now, the next rule says the number of electrons gained in the reduction half equation must be equal to the number of electrons lost in the reduction half equation. So remember, it was just 2 electrons that were lost here, and it was 6 electrons that was gained here. So we'll just do a simple mathematics. We'll multiply this one by 3, and multiply this one by what? By 1. So if you multiply this by 3, so the 3 will multiply everything. So this becomes 6Cl minus, 3Cl2, and 6E minus. So making our electrons to be what? Equal. That's what we need to achieve for that step. So once it's equal, we are good to go. So now the number of electrons involved in both the oxidation and reduction half equations are the same. So addition of the 2 half equations give the final equations. So once they are now balanced, so we now add it up together. And that is the end of balancing that redox what? Reaction. So I believe we have been able to understand that. Let's move on to the next. Okay, this is emphasizing all what we have done, how YH plus and water is added, which I've told you before. So now this is a question here. So I'll leave it for our students to be able to do. We'll follow what we have earlier done, so that we can understand it ourselves. So we balance the reactions. It's a WAEC question, and they have helped us to let us know that hydrogen plus will be on this side and water will be on the other side, just like the way it was in the question that what we did. So remember, the first thing is to identify the oxidizing agents and the reducing agents. What do you think will be the oxidizing agents, my fellow students? Very good, very good. It is MnO minus. That will be the oxidizing agent, because it is moving from what? +7 to +2. So it is undergoing what? Reduction. Unlike iron, that is moving from +2 to +3. Iron is undergoing what? Oxidation. Remember, we said oxidation is increase in oxidation number. So with that clue, I believe you should be able to what? To solve it. Now these questions to follow the same similar what? Pattern. We are well aware of this man, so it shouldn't pose difficulty to us. So we'll balance it atom-wise. Remember, balance atom-wise first, then balance what? Charge-wise. It's very easy for you to do. At the end of the day, once you check your atoms, you check your charges, you will find out they are what? Equal. Then your answer is as good as good. Okay, students, let's take this practice question. Let's try it. I'll give you some time. Please, let's go through it.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
Welcome back. I believe we have gone through and we have our answer. Oh, I heard somebody say option A is the answer. Option A, you did not go through it very well. Because the question says, which of the following reactions is a redox reaction? If you look at option A very well, the oxidation number of all the participating elements, both on the left and the right side, are the same. They are not changing. If you look at calcium, calcium is +2 here. Calcium here is +2. Oxygen is -2 here. Oxygen is -2 here. Hydrogen is +1 here. Hydrogen is +1 here. So they are not changing. So such reactions are called non-redox reaction. non-redox reaction. In another exam, in another format, you might be asked which of the following is not a non-redox reaction. So probably you got me wrong. That's not the question I'm asking. The question I'm asking is which of the following is a redox what? Reaction. So our correct answer is option B. Our correct answer is option B. Why is it option B? Because in option B, there is a change in oxidation number. Let's quickly check it out. We have hydrogen here. Hydrogen here is +1. Hydrogen here is 0. Why? Because it is on its own. Hydrogen is on its own. I remember we said that the oxidation number of an element in the free state is 0. So hydrogen here is 0. But here, hydrogen is +1. So it's moving from 0 to +1. I believe you know what that means. Is it oxidation or reduction? Very good, oxidation. Why oxygen here too is what? 0, because it's in its free state. So it's moving from 0 to -2. So they are undergoing changes. So that is why it is a redox reaction. If you look at the others, they are not undergoing changes. They still remain what? The same. So that is our answer. So our correct answer is option B. So thank you very much, students. Please keep practicing, because the more you practice, the better you understand.
Eko Learners Support, a support program of the Lagos State Ministry of Basic and Secondary Education for WAEC and NECO candidates.
And for any question, comments, or suggestion, please reach out to the link displayed on the board. Thank you very much.
Acing your WAEC and NECO examinations has been made easy by the Lagos State Ministry of Basic and Secondary Education with the Eko Learners Support for WAEC and NECO candidates television program. Join seasoned teachers as they take you through these core subjects: mathematics, English language, physics, chemistry, and biology, targeting the exact syllabus of WAEC and NECO. Watch Eko Learners Support for WAEC and NECO candidates on this station. Learners can also connect with Eko Learners Support for WAEC and NECO candidates through these social media platforms to access more educational content and give their feedback. Eko Learners Support for WAEC and NECO candidates. Pass your examinations with flying colors.